But suppose that I have a little box. Okay, a little box there, and let's say it's a metal box. Now I'm going to prepare a bunch of tiny little ball bearings. The ball bearings here. Okay, the ball bearings. We have a bunch of these little ball bearings, and I'm going to drop the whole lot. I'm going to drop the whole lot into the ball. Yeah, into the box. Okay, drop the whole lot into the box. Now let's say I have say 10 of these ball bearings, and the mass of each one is, let's say, 0.01 kilogram. 10 grams for ball bearing. That's might be a bit heavy, but okay. But let's say I have let's just say that I have 10 of them. Okay. Now I'm going to drop them, and I'm going to drop them all from a height of, let's say, from a height of quite a big height, maybe 10 meters. From height of 10 meters. And they all fall into this metal box. Now this metal box here, when the ball bearing falls into the box, they would bang around, bounce around for a bit, and then they'll stop. And what happens to this energy from the ball bearings? Well, after they've stopped moving, this energy, we would expect that this energy will be converted to heat energy in the box, meaning that this box should warm up. Temperature should increase a bit, depending on how much energy it got from the ball bearing. So what I like to do now is to think about how I can calculate the increase in temperature, right? The increase in temperature of this box. Okay. Now let's say that the volume of the box. Okay, the volume of the box is no, not volume. The mass of the box. Let's say the mass of the box is 1 kilogram, and I need some information to be able to do a problem like that. I would need to know how this box, how the temperature of this box changes with the heat that you put in. So I need to know something called the heat capacity. The heat capacity of the box, let's say, is I just say it's 300 joules per Kelvin. Okay, 100 joules per Kelvin, heat capacity of the box. So every time it receives 300 joules, temperature would increase by 1 Kelvin or 1 degree Celsius. Okay, so let's say that's our setup right now. Now, so I'm going to go up 10 meters. So 10 meters, a bit high actually. Maybe I'll go up to say the 3rd floor of a building, and I'll start dropping my ball bearings into the box. So if I'm very accurate, they will all fall in the box, bounce around a bit. Hopefully they don't jump right out. And after that, when they settle, they will have lost all the energy to the box. Now I want to find out the increase in temperature of the box. So how can I do such a problem? Okay, now the way is to first start by you thinking of the idea of energy conservation. We say that we know that energy cannot be created or destroyed. So when I hold the ball bearings at a 10-meter height, this ball bearing has potential energy relative to the box. So that when I drop them, this potential energy will be changed to kinetic energy, and when the ball bearing hit the box, that kinetic energy will be changed into heat. So this is what happens. At first, I have this potential energy when it is at the 10-meter height, and when it falls, right, just before it hits the box, this is in the form of kinetic energy. Okay, so this is where we are when it's at the 10-meter height, right? This is just before the box. Okay, and after that, after it hit the box and stopped, it will be converted into heat energy, which I'll call Q. Right, this will be the heat in box. Okay, and because of energy conservation, when when it falls to the box, all the potential energy goes to zero when the height becomes zero. But they're not destroyed. They must be changed by the exact amount into the kinetic energy. So that's why we have an equal sign. And when it stops, all the kinetic energy becomes zero. Right? When they stop bouncing, all the kinetic energy becomes zero, and again, this energy is not destroyed. It's just changed in another form, into the form of heat in the box. And again, these two amounts must be exactly equal because no energy can be destroyed. Okay. So that's the heat. So question now is, I want to find the increase in temperature. So the way to do it is to first find this heat and then to use the heat capacity, I'll call this C, to find the increase in temperature. Okay. Now, to find the heat, I can start by finding the potential energy because I know the formula for the potential energy. So let me do it this way. I'm going to say, right, I want to find the heat. Okay, that's my first step. I want to find my heat. And to find the heat from this energy conservation idea, I know that the heat gained by the box must be exactly equal to the starting potential energy of the ball bearings. And I know the formula for finding potential energy. It is mgh. Okay. So what can I do with this? I can substitute numbers into here now. So that's my h. That's the h. That is the m, the mass. But remember that we have 10 of them. So what I have to do is I have to take the point 0.01 for each ball bearing, 0.01. I must multiply by 10. Multiply by 10. And after that, I must multiply by g, acceleration due to gravity, which is 9.81. 9.81. And then I must multiply by the height, which is 10 meters. 10 meters. Okay. So I can find an answer. So 10 times this times 10 becomes 1. So the answer is just 9.81. And this would be in joules. Okay, in joules. So this is the amount of heat that would go into this metal box. Now, okay, according to this heat capacity given, for every 300 joules of heat that goes into the box must increase by 1 Kelvin or 1 degree Celsius in temperature. Okay, so what happens when 9.81 joules go into the box? So we can just do a fraction, right? Just take 9.81 divided by 300 joules. So let me write that out. Okay, so therefore the increase in temperature is equal to, just write it out here, 9.81 divided by 300. That's it, really. And I can simplify this quickly. I can use a calculator, but let me just do it by hand. So if I cancel out, divide the bottom by 3, a bit of 1 there, divide 9 by 3, I get 3, divide 81, that's a bit tricky. Okay, this 81 is 9 times 9, right? This is 9 times 9. I'm going to divide one of this by 3, and get 3, and 3 times 9 is 27, so 3.27. 3.27 over 100, and that is 0.01237 Kelvin. Alright, or degrees Celsius. That's the increase in temperature by 0.0377 of a degree. You would hardly feel this. If you touch the box, it would probably not even feel warm. Alright, but we can but actually there is an increase in this energy. And if you really want to check that this conservation of energy that is really correct, we can actually measure the amount of heat that is the increase in the temperature, right? And check that it is the correct value. Maybe that if that's too small to measure, we can use 100 or even 1000 ball bearings, and just to get a few degree rise in temperature that we can measure. So by doing actual experiments and measurement, right, we can actually show that this energy conservation idea, result, or law is true.